true labor of love. So I am Dead Program. In the real world, I'm Ron Evans, but that's not very important right now. I'm the ringleader of the hybrid group. So this other guy over here is A.D. Zankich. He's the serious programming guy at the hybrid group. So that means he does all the work and I take all the credit. Awesome. So we're with the hybrid group. We're a software development company based in Los Angeles, California, home of the flying space robots, and that's not a joke. If you're a fan of either the Jet Propulsion Laboratory or SpaceX, you know I can't make this stuff up. It's too amazing. Anyway, we're also the creators of Kids Ruby, which is an open source tool for teaching kids programming. Won the Fukuoka Ruby Awards 2 years ago and gets about a terabyte of downloads a month. But we're here to talk about JavaScript robotics. Gzz. So this is Maria. She is the leader of the robot proletarian revolution, but that's a whole nother talk. Let's move on. So the future is already here. It's just not very evenly distributed. At least that's what the futurist and author William Gibson said. And isn't that really true? For those of us who all live in the future, we've already gotten bored of the things that normal people haven't heard of yet. So we are here to talk about our open source robotics framework, Cylon.js. It's a JavaScript framework for robotics, physical computing, and as it's now trendily known, the Internet of Things. It supports multiple hardware devices, different hardware devices, and multiple different hardware devices at the same time. Thank you, Node. So this is a little quick architecture diagram of how it works. We don't have much time, so we'll just kind of blast through it. The main thing we care about is the robot. So we're using two different design patterns, not visual, but in fact software architectural design patterns. The first one is the adapter pattern. We have something in Cylon called adapters. It's very similar to the way an object relational mapper works in a database. So you can switch between different kinds of hardware and use the same code the same way that you could switch between different database backends without changing your code. We're actually using the adapter pattern again, the secret double adapter pattern, with something that we call devices. So we can have our devices like a button or an LED and our connections like an Arduino or a Raspberry Pi, and you can mix and match them. So you can support any hardware on any platform. The other pattern that's interesting is we're using publish and subscribe pattern. If you're a Node programmer or JavaScript non-Node programmer, then you're quite familiar with emitting events and catching those. So we fire these events from devices into the robot so it knows when things have happened. All right, so of course we have an API because internet-controlled robots is what else good is a robot these days if you're not controlling it over the intertubes? So you can connect via a RESTful API that's built right in, or you can use WebSockets or server-side events. You communicate with the API, and then it talks to something that we call the Master Control Program, or the MCP, and that will communicate with your robotic swarms. All right, so test-driven robotics, that's another thing we think is very important. If Toyota, I drive a Prius, but if they'd only used test-driven robotics on their braking systems, how much less tragedy would have occurred? And that's not a joke, it's quite serious. And we, of course, have a command line interface because CLI is the new API. We actually have that pulled out into an entirely separate project called Gort. You can check that out at gort.io. All right. And last but not least of our preliminaries, Robot Ops. It's DevOps for robotics. We want to get lots of people involved in this because there's a lot of interesting lessons learned. We have a whole site set up, robotops.com. So on with the actual show. So let's start with an Arduino. Now, who here knows what an Arduino is? Excellent. So the Arduino is kind of the most common microcontroller. We're going to actually be controlling it using Cylon. And so his computer, yes, cut to the camera. So yes, you've seen this before. This is a stock Arduino Uno, except it's also had the Fermata sketch, which is a generic serial protocol that's used by many, many different open source projects. Cylon.js uses it, Johnny 5 uses it, our other open source robotics platforms use it. So we're going to plug that in, and then the code we're going to write looks a little something like this. So first we declare Cylon, and we require Cylon. It's a node module. And it's a node module that can pull in the other node modules that it needs dynamically. So we create Cylon.robot, and we declare our connection. Its name is Arduino, and it's using the Fermata adapter. If we were going to be using a different kind of hardware platform, that's where we would change it. And we're connected to port dev TTY ACM0, which is the default serial port if you're using Linux, which is the operating system of robotics. You should switch to Linux. All right, that's a different talk. So then the device we're going to talk to is an LED. It's using the driver for the LED, and it's connected to pin 13. And then the work that we're going to do is that every 1 second, we're going to my.led.toggle, which is going to turn the LED either on or off, and then last, we're going to start it out. So if the programming gods of live demos have heard our supplications appropriately, we're going to run this code, and it should start flashing on and off.
Yeah, it's kind of hard to see, but it is blinking.
Yeah, this is our universal video adapter. It works on everything. It's called a camera.
Yeah, so this, yeah, pin 13, that's the built-in LED.
Okay, gratuitous applause.
Yeah.
All right, we know that's gratuitous because you've all actually seen blinking LEDs on an Arduino before, but let's show you a Tessel. All right, so Tessel is a JavaScript-controlled microcontroller. In this case, we're actually going to put the JavaScript code on the board itself. So we're not going to be running and controlling it from the computer and just sending serial commands. We're actually running JavaScript that has been compiled and running on the Tessel itself. So let's take a look at the code real quick. It looks almost exactly like the other code that you just saw. In this case, the connection is named Tessel. It's using the Tessel adapter. The device is an LED, and we're switching to pin 2, which is the built-in LED on the Tessel. And then it's the exact same work routine. We're just every 1 second my.led.toggle. So this was the Arduino code. This is the Tessel code. So with my very skilled camera operator techniques learned in Los Angeles, so we're actually going to download the JavaScript code to the Tessel and then run it on the Tessel board itself after we reboot it. Tessel's not out yet, but it will be very, very soon from our dear friends at Technical Machine. This is how you know it's real. Think, 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 think.
Small technical difficulty, 1 second.
Please stand by. Please stand by.
There we go. All right. So then now you can see this output on my computer. The Tessel is compiling the JavaScript code, bundling everything up. Now it's deploying the script. You can kind of see it on my computer. So now it's running the script. You can see it's entering the Cylon initialization routines. So now it's running the Cylon program. And now the light's blinking.
Another blink. Applause.
So this is plugged into my computer just for the power. So if this was powered by some external source, we would have a JavaScript program running on this board independent of my computer entirely. So Cylon.js is the firmware that's running on this board currently.
All right, moving on, because we have very little time. We have lots of time and little to do. Wait, strike that, reverse it. All right, so this is now the time for your choose your own hardware adventure. Yes, we're back in the physical things, and choose your own adventure is a thing. So you actually have your choice. So prepare to tweet to win an Arduino starter kit. Arduino starter kit from Adafruit and from our company. Comes with everything you need to get started with physical computing. Just tweet Arduino and Cylon.js. If you want to win a Pebble smartwatch, of which we have support for, tweet Pebble and Cylon.js. So I'll repeat that again. To win an Arduino, tweet Arduino and Cylon.js, and or to win a Pebble, rather, tweet Pebble and Cylon.js. So we're going to give these away at lunch. We have a table upstairs with a bunch of t-shirts and stickers, and if you tweet, we're going to very arbitrarily decide based on completely random factors. On with the show. Sphero plus Pebble plus Robo. So what are we talking about? So the Sphero robot is a very small Bluetooth-controlled device from our friends at Robotics out of Boulder, Colorado. It's actually what you might consider the minimum viable robot. It has input, it has output. So its input is that it can detect collisions via its built-in accelerometer. Its output is that it can roll around and it can change its color through the RGB LED, which is built in. So additionally, we're going to connect it to a Pebble smartwatch, and to our universal API built in AngularJS Robo. So who here knows what Conway's game of life is? Excellent. I love the fact that Edinburgh is such a mathemagical place. So for those of very, very few human beings who don't know what this is, John Conway, not John Connor, that's a fictional character, John Conway, mathematician and man obsessed with seemingly simple but yet complex emergent phenomenon. He notices that flocks of birds, and birds not being particularly intelligent, but yet somehow they're able to fly in these amazing formations. He begins to analyze this, and he comes up with a whole new branch of mathematics. We call it cellular automata, or as it's popularly known, artificial life. So Conway's game of life is played on a pad of graph paper. Each one of these little circles is a cell. Each one of the squares is just a blank space. So the rules go a little something like this. When a cell has less than 2 neighbors, it dies from loneliness. If it has 3 or more neighbors, it dies from overpopulation. And a blank square has a new cell born into it if it has 2 neighbors. So if our first move was like this, our second would be something like this. All right? So we thought it'd be really cool to do Conway's game of life, but with robots. But we realized we would have to make a few little adjustments. One of them is that the Sphero robot does not possess any ability to see. So it cannot recognize where the immediate neighbors are. Also, we can't cause new Spheros to be born out of thin air. That would be really neat. That's a 3D printing talk that will be coming soon. So we had to make a few little changes. But luckily, thanks to the magic of what is known as an inverse Fourier transform, we can take a slice of time and break it up and then detect each of the collisions, and utilizing the number and frequency of collisions, we can basically create an estimate of the number of neighbors that we've encountered. You guys got that? Good. So here's the code. So first we declare Cylon again, require Cylon, and this time we're going to declare a hash that contains the port for each of our robots and then the names, Thelma, Louise, Grace, Ada, and Mary. So we declare a couple of constants, green and red, and now we actually declare the code, the same code that's going to be run by each of the robots. We have a connection to the Sphero adapter. The device is the Sphero device because Sphero has its own little API that's unique to it. When a Sphero is born, we register it has 0 contacts. We say it's alive and that it can move. Moving around will move in a random direction at a speed of 60. When it's alive, it turns green. When it's dead, it will turn red and stop. If it's had enough contacts, then when its birthday comes along, then it stays alive. Otherwise, if it's had enough contacts when it was already dead, it comes back to life. Zombie mode. Zombies are so cool. And then, of course, if it doesn't have enough contacts, it dies. Then the work that each of these is going to do, it's the same work. When it connects, it's going to start to detect collisions and be born. Then each of the collisions will register. Every 3 seconds, if we're still alive, we move. Every 10 seconds is our birthday. So life is very short, hard, and spherical in Spheroland. And so then we're going to declare each of the arrays, or each of the bots. We declare a new Conway robot. We define its port and its name, and we tell Cylon about it. All right, so on to the Pebble. So the Pebble smartwatch, you can control it via JavaScript, via your smartphone. It's got a little container application which will then communicate via Bluetooth Low Energy to your smartwatch. So in this case, we're creating a connection to the Pebble adapter, the Pebble device, and the work that we're going to do is we're going to, every time that there is a collision, we're going to count those up, and then we're going to be able to send those notifications to our Pebble smartwatch. All right? And so we tell Cylon about that robot. We then declare our API, which is going to be running on a particular port, and then we start the whole thing off. So, if the demo gods are on our side, we're going to see them turn green and start rolling around as they come to life. We keep them within our little petri dish or cage, containment vessel. It's made from PVC. We brought it here. Believe me, we got a few questions at security. Why do you have those glowing spheres and these PVC tubes and all this homebrew electronics? We're going to a conference? Okay, here you go.
Okay. Initiating game.
Stand by. They live. So now it goes on for a random amount of time. Ooh, wow. It was a massacre. So let's take a quick look at our API. So this is Robo. This is an AngularJS app. It's actually communicating with the API that's running it right now. So we saw all our different robots. And if we take a look at the Pebble one, and we look at the Pebble device, we can send it some commands. Let's see the last message that it sent. So 2 are alive, 3 are dead. Yes, that is correct.
And then if you go to the...
If we go to the camera,
You can see here on the Pebble Watch, it's slightly difficult to see, but right now I'm hitting the Cylon
really
server
blurry.
API. Yeah, it's a little hard to see, but I'm hitting the Cylon server API, which is generating a report of the current game. So you can see here it says there's 1 alive and there's 4 dead.
yeah. We hate to kill artificial life and natural life the same. But we're very, very pressed for time. So without further ado,
I'm a murderer.
terminate. Terminate. All right, moving along. So now we've promised you flying things, and so flying things shall ye receive. Now we've all seen the AR drone, especially those of us who have been to a Nodecopter event, but what you maybe haven't seen is AR drone with OPENCV. OPENCV is an open source computer vision, I would call it a platform, because calling it a program really does it a great disservice. It's a very sophisticated computer vision platform. It can be used for many, many different kinds of applications. In this case, we're going to do facial recognition of our test subject, aka target, aka volunteer.
Yeah, so...
You knew him when.
Like,
Witness him the way he is right now, because he will be irrevocably changed by this experience. All right, so here's the code. Once again, we require Cylon. We pull in our har cascade, which is an XML file that OPENCV uses. We didn't train our drone for his particular face, so it just recognizes anyone's face. So if you feel sorry for him, throw yourself between him and the drone. So the 2 connections we're going to make, one is to OPENCV, the other is to the AR drone itself. Then we have 3 devices, the drone, which is the flight commander interface, how we're going to fly it, a window so that we can see what the drone sees, and then MAT, which is short for matrix, which is what we all know what that means, right? In this case, it's what it uses to recognize us as human. Yeah. All right, so the work function we're going to do is my drone, we're going to get the PNG stream. Each one of these frames, we're going to read it in, and then we're going to feed that into our window so we can see what it's seeing. Then when it detects faces, we're going to actually, the biggest face, by the way, so the closest one is what that usually means. We're then going to draw a green square with rounded circle, or corners, because rounded corners are so cool. And basically, it is going to look, and if he moves to the left, it will follow him to the left, and if he moves to the right, he will be followed to the right. There is no escape. So then the drone's going to take off, and after 8 seconds, it's going to kick up to face level, face hugger. Then after 10 seconds, it's going to hover. After 13 seconds, it will begin to detect. Every 0.3 seconds, it will detect a face and make the appropriate adjustments. And then after 30 seconds, if we are lucky, it will just land on its own. Yeah. So, whoops, sorry. So with my universal video adapter, it always works.
I'm going to start this program and then jump over there.
Yeah. We're not actually insured for this.
Okay.
Ah, yes.
Yeah, so if you move...
Go ahead, try to escape. See what happens.
You're out of its range. No.
Not for long.
There it goes. You're an easy target,
is an
man.
eternity.
Yeah, you can move now. Oh, there it goes.
All right, so we have one more demo for you guys. So this time we're going to show the AR drone with OPENCV with free flight as controlled by a PS3 controller, and then using this. It's a NEUROSKY mind wave, so we're going to actually use this not to fly the drone, but to check out the state of mind of the pilot. You don't mind putting this on, do you?
My brainwaves, my precious brainwaves.
All right, so let's take a quick look at some code. So it's pretty much the same code as what you saw before. We're using OPENCV. This time we're also declaring a connection to the DualShock 3. We support a couple of different joysticks. We're pulling in OPENCV again, and we're also adding the controller for the DualShock 3. This time, though, instead of doing facial recognition, we're going to validate our pitch data to make sure we don't try to fly upside down. Then the work routine we're going to do, again, we're grabbing the PNG stream so we can see what the drone sees. Then each of the controller buttons are going to do different things. Pressing square takes off, pressing triangle hovers, pressing X will cause it to land, right? And
I think so.
The right stick will control the, let's see, what does the right stick control? The left stick controls the pitch, and the right stick controls the yaw. And then every 1 second we're going to hover, and then we start. So additionally, we're going to run another Cylon program, which is going to look at his brain. So in this case, we're going to declare a connection to the NEUROSKY, or as we call it after being in Poland, the NEUROSKY. So the NEUROSKY will read his brain. And then the work it's going to do is that it's just going to pull the EEG data and then display it. And so then, let's see. No, that was not fun. Where's my link? Let's see. What was the IP address? Oh, no, that's right.
It's a local, yeah.
Yes, so it is. So there's his brain on JavaScript. And so here's what the drone thinks of all that. Stand by. So this is a human-controlled flight, so it's very non-deterministic.
Yeah. So if you see my brainwaves freak out, stand back.
Standing by, Houston. And we have liftoff. I don't see the video updating though.
Oh yeah, I think the stream may have been frozen. Let me see here. Hover this, I'm gonna do a little, let's see if my brainwaves show that I'm multitasking here.
He looks nervous.
I don't want to force quit this program. Yeah, I think that we lost the video here.
Yeah.
But we can
Why
still
don't you
control
fly the
it.
drone?
Yeah.
We have a lot of altitude. Hint,
Yeah.
hint.
I want to whip some people's hair though.
Yeah, I know. Now he is conference rated. We have an obstacle course you have to fly through twice without crashing. I am not.
Which I designed, so I gamed the system.
I never knew that.
How would we know if you're multitasking with your brainwaves?
Well, this is actually
Yeah.
pulling the actual EEG data itself. You would need a real neuroscientist to interpret this data.
Yeah.
We are not scientists, we are technologists.
So now do a little land here.
Almost there. Yes! And no humans were killed during that demonstration. So was that fun? Did you guys have a good time? So we love doing this kind of stuff, and it's also a magnificent new opportunity to think of new kind of computing applications. Because when we say think outside the box, we mean like way outside the box. So join the robot evolution, not revolution, because we want to create a new peaceful era where robots do all the work and we just hang out and have a good time. So check it all out, cylonjs.com, or follow us on Twitter at cylonjs, and we thank you very much.